Hello guys, welcome back to Maths on African Motives. Still working on mathematics N5, that is working on our logarithmic differentiation. In this case, we've got questions that we are going to consider, whereby you'll be applying the logarithmic part of your derivatives. So this is actually used on most complicated cases. That is where you apply the logarithmic part, whereby you'll be given formats of, for an example, y is equal to f of x, whereby you are dealing with a function of x being raised to another function of gx like this, and most complicated situations. So in this case, how can we apply our logarithmic part? So I'm going to explain with these questions so that we can understand much better. We are given to calculate dy dx if y is equal to 1 minus 3x raised to the exponent of cos x. With aid of logarithmic, you are also given what to use there. So if we take here, we've got a function of x. We also have another function of x there, raised as an exponent. So what you do, these are the steps that you're going to take. The first step is to introduce the logarithms into this part that we are given. We are given y is equal to 1 minus 3x, in this case, to the exponent of cosine of x. So what you do is that you're going to introduce the logarithms for both sides. So introducing the log, we are dealing with the ln. So the ln of y is going to be equal to the ln of 1 minus 3x to the exponent of cos x. The moment you introduce logarithms, we introduced ln here, we introduced ln here. That is the condition that I'm saying you introduce both sides. The moment you introduce the logarithms, if you check on the right-hand side, there's a law that can be applied because it's a log, this part, raised to a certain exponent. And we understand from our laws of logarithms that if we have let us just write a, whatever letter that you want, or you can just have m here. M, the ln of a is the same as the ln of a to the exponent of m, meaning to say m is going to be raised to be an exponent. When raised as an exponent like this, m is going to be dropped to multiply the log. So this is the reverse that we are taking to this stage. So here we've got ln and an exponent, which is m ln n. That is, we are going to multiply with the cos of x, which is representing what? Our m in this case, all right? So that means we are going to have the ln of y is equal to, if we take note, we drop this, we are going to have the cosine of x multiplied to ln of this part, which is the ln of 1 minus 3x, like this. All right, so this is what we have. So what you are going to do is to find the derivative of y with respect to x. So that's d dx, the derivative of y with respect to x from both sides. All right, remember from our implicit functions here, we've got ln of y, meaning to say we can't determine dy dx direct. We are going to find the derivative of ln, which is 1 over y in this case. All right, remember the derivative of ln, that is going to be 1 over y multiplied to the derivative of y with respect to x. So that's how we use this in our implicit function. If you are given 2y like this, and you're asked to find the derivative of y with respect to x, you differentiate this part, which is 2 times dy dx. Since you are not having x, you just differentiate as it is, but don't forget to put what? Dy dx at the end. So that is what you're going to do on this part. But if we check on this side, that is our right side of our equation, we are having a product there. These two terms, they are multiplying each other. So meaning to say we are having our u and we are having our v, which is the ln of 1 minus 3x. Remember from our product rule, guys, from our product rule, that if you are to differentiate from our product rule, it is going to be u, the first derivative of v, plus v, the first derivative of u. So in this case, we are going to take our u as it is, u, which is cosine of x. So that is going to be cosine of x multiplied toward the first derivative of v, which is ln x. All right, remember the derivative of ln, if we are differentiating ln with respect to x, in this case, that's the derivative with respect to x of ln f of x. If we are given ln f of x, it is going to be the derivative of f of x over f of x in this case. So take note, meaning to say this is your f of x. So from this part, the derivative of f of x, which is the derivative of this part 1, that's a 0. The derivative of minus 3x, it's minus 3 over f of x as it is, which is the function of x, this part as it is, which is 1 minus 3x. So that's how we differentiate ln f of x. So meaning to say, here we are going to obtain minus 3 over 1 minus 3x like this. Okay, plus, so you're going to have plus v, our v, which is the whole ln of 1 minus 3x as it is. All right, so this part is going to be multiplied to the first derivative of u, of which our u is cos. The derivative of cos, remember, that's negative sine of x. So this is what we're going to obtain from the derivative of this product that we had on the right hand side. So all we need here is to simplify further so that we can introduce back our y in this case, which is equal to, let us simplify here, this is same as cos x over 1. So we can multiply these two, cos x times negative 3, numerator to the numerator, that is going to be negative 3 cosine of x over 1 times 1 minus 3x, that will be 1 minus 3x, all right? Here we just combine negative and positive is going to give us a negative. So I prefer starting writing with a sign. So I'm just going to start with sine x followed by ln 1 minus 3x like this. Like this is separate. This part is separate. So here we can multiply this to a negative, which is going to be negative sine x, plus positive and negative gives us a negative. But if we check here, the question here is to find the derivative of y with respect to x. This is what we are asked to find. So we can get rid of this 1 over y so that we remain with the dy dx in this case. All right, so how can we get rid of this 1 over y? To remove 1 over y, you simply multiply by the inverse, which is y over 1. So meaning to say this whole side here, we are going to multiply by y over 1, of which y over 1 is same as y, because the moment we cancel this, we remain with dy dx. So that means the derivative of y with respect to x is y over 1 times the whole of this bracket. So that's y into the whole of the bracket minus 3, the cosine of x over 1 minus 3x minus the sine of x, the ln of 1 minus 3x in this case like this. All right, so that is what you're going to have. But if we are to check, guys, y is being represented before in this part that we introduced. We said y is equal to the whole of this part. So wherever we see y, we are going to substitute with 1 minus 3x to the exponent of cos x. So this is the one that you are going to substitute on your final answer now. So therefore, the derivative of y with respect to x is going to be the y that we had before, which is 1 minus 3x to the exponent of cos of x. Everything being multiplied to this whole part that we have in the bracket, which is the negative 3 cosine of x over 1 minus 3x minus the sine of x, the ln of 1 minus 3x, this whole part here in the bracket. All right, so you can actually leave your answer at this stage. You can leave your answer at this stage. So these were the steps that you're supposed to take whenever I asked you to find a derivative using the logarithmic. Introduce your logarithms, then apply the derivative, finding y with respect to x. So on the right hand side, you have to apply whatever concept that you have, but mostly it is going to be a product. Mostly you are going to obtain a product. Let us check this part again and see what you're given. We have again to calculate the derivative of y with respect to x given this part and with aid of our logarithmic differentiation. All right, so like I said, the first thing is to introduce the ln which is the logarithm. So we're going to have the ln of y is equal to, we introduce ln here, that is going to be the ln of 2x minus e to the exponent of 8x, everything to the exponent of sine x. Remember the law that we used of logarithms. Once we've got a ln, it's a log. So the exponent is going to be multiplied on our log in this case here. So that means we are going to have the ln of y is equal to the sine of x into the ln of 2x minus e to the exponent of 8x, like this. So this is what you're going to have. So as you can see, we are simply back to the same part that we had in the previous case, whereby you are supposed now to find the derivative of y with respect to x. So we are supposed to differentiate. Here we do not have x, there is a y there. So you differentiate ln, which is 1 over y. All right. But knowing that we are using the implicit function, so it is going to be dy dx, which is equal to, what are you having on the right-hand side is a product where this is your u and this whole part of ln is representing your v. So you are back again to the product concept where we say the derivative of a product is going to give us u, the derivative of v, plus v, the derivative of u. So in this case, our u, that sine of x, is going to remain as it is. So the sine of x multiplied to the derivative of v, which is ln. Remember what I said about ln? The derivative of ln f of x, if you are differentiating ln f of x, in this case, it is going to give us the first derivative of f of x over f of x. So that's in this case, we've got ln this part, which is your f of x. So we need its derivative. So let's differentiate 2x is going to give us a 2, all right, minus, how do you differentiate e? Remember e, we drop this exponent, the derivative. Let me just write on top a little bit here. Remember the derivative of e, if you are given e to the exponent of f of x like this, it is going to be the first derivative of f of x e to the exponent of f of x. So the derivative of our f of x here, which is 8, so that is going to give us 8 in this case, okay? Then e to the exponent of f of x, which is e to the exponent of 8x, everything over our f of x as it is, which is this whole part of 2x minus e to the exponent of 8x. So this is what we're supposed to obtain from this derivative of ln. We are obtaining 2 minus 8 e to the exponent of 8x, everything over 2x minus e to the exponent of 8x. All right. Then whatever that you have here, we are supposed to add v, which is our v, the whole part of our ln. This is representing your v. So that's the ln of 2x minus e to the exponent of 8x multiplied to the first derivative of v, which is our sine x, which gives us a cosine of x. So this part just take from our formula sheet also, and basic derivatives, as we know, guys. So like I said, you can simplify, but here let us multiply as we are simplifying. Remember here I said you're going to multiply by y this side. Also, you multiply this side by y here so that this one and this one cancels. So that means we are going to have dy dx, which is equal to the y multiplying the whole of the bracket here. But let us just simplify. This is same as over 1 here. So we're going to multiply sine x to the top. It's going to be the sine of x in this case. All right. Okay, I want to check something here. All right, I'm having 2x, 2x there. Sorry for this part. This was sine 2x. So let us just try to correct this one. Sorry for this. So this was 2x. I'm wondering what's happening on my answer there. This is also 2x. This is also 2x here. This is going to be 2 cos 2x. Remember, if you are given a 2, the 2 multiplies also here. I just hope this is where our 2 was affecting. All right, let's just hope so. So this was going to be sine of 2x into 2 minus 8 e to the exponent of 8x as it is here. over, then we multiply 1 times the denominator, which is 2x minus e to the exponent of your 8x, like this. All right. Then this whole part, you can just start with your trig, which is 2 times this is a plus, so it's going to remain as 2 cosine of 2x as it is this part, then times the ln of 2x minus e to the exponent of 8x, like this, close the bracket. All right, so this is what you're supposed to have, but knowing that before we have this y given, so y is the whole of this part that we have here, so we are going to take this whole part in place of y, substitute the bracket, this whole part as it is, so we now have the exact derivative of y with respect to x. So therefore our derivative of y with respect to x was going to be, remember y there, the whole expression was given as 2x minus e to the exponent of 8x, okay, in a bracket like this. All right, so this was in a bracket to the exponent of sine 2x. So that was to the exponent of sine 2x. So this is the x part for y. And this bracket is going to remain as it is, meaning to say we are going to have sine 2x into 2 minus 8 e to the exponent of 8x as it is this whole part. All right. That's going to be 2x minus e to the exponent of 8x plus 2 cosine of 2x ln 2x minus e to the exponent of 8x, like this. All right, so this was what you were going to obtain at the end. At the end, you're going to have this part. All right, so that's how we play around with our derivatives whenever we are dealing with this type of equation. As you can see, it's just a straightforward derivative and substituting of y in the last part, which you are not supposed to forget to do. All right, we have another question again of the same part. Y is equal to x to the square root of x, which is your f of x, your gx, with the aid of logarithmic differentiation. Calculate dy dx. All right, so we are back again. Introduce ln as we said before. So that is going to be ln y is equal to, here we introduce ln, so that will be ln x to the exponent of the square root of x. We are back again whereby we've got an exponent. We have to drop our exponent here. So that is ln of y is equal to the square root of x by the ln of x, which is a product again. So you see that every part is going to end up on a product. So find the derivative of y with respect to x, but here we do not have x. So we are going to differentiate ln, which is 1 over y dy dx, which is equal to the product. Now, remember that this can be written as x to the exponent of a half times the ln of x, that's square root of x. So we have our u, in this case, we have our v, and our product rule, as I said, that is going to be v, the first derivative of u. So we need u in this case as it is, which is this u v. So our u is x to the exponent of a half, which is square root of x. So you can just write it as what? Square root of x. Okay, by the first derivative of v, which is ln. So remember, guys, this is ln, just like ln y is 1 over y. So if it is ln x, it is going to be 1 over x, all right, plus v, our v, which is ln. So that is going to be ln x, which is being multiplied to the first derivative of v. So to use a square root is difficult than to use what? X to the exponent of a half. So we are just going to work with x to the exponent of a half, where we drop our exponent, which is half x to the exponent, you subtract 1. So that will be a negative half in this case. Okay, which we take further as to remove the 1 over, it's going to be 1 over 2 square root of x. All right, so meaning to say here, we are simply having 1 over 2 square root of x, all right, in simplest form. So this is what you're going to have at the end. You can simplify your square roots, which is fine. You can just try to simplify like this part here. Remember, you are multiplying. So what does it mean? Remember, we said the square root means x to the exponent of a half. So it means we've got x to the exponent of a half, which is multiplied to 1 over x. 1 over x means x to the exponent of negative 1. So remember, if you're multiplying the bases which are the same, you add the exponents. So that was going to be x to the exponent of a half plus -1, which was going to give you x to the exponent of negative half. Half plus -1, that will be a negative half in this case. And 1 over negative half, I mean, to remove this negative, it was going to be 1 over x to the exponent of a positive half, which is 1 over the square root of x. So meaning to say, this whole part that we see here, it is going to give us 1 over the square root of x when simplified further from our laws of exponents. So that's 1 over y dy dx is going to be 1 over the square root of x. All right, plus here we can just multiply. This is same as 1 over ln x over 1. So it's ln x times 1, which is going to be ln x. 1 times 2 square root of x, which is going to be 2 square root of x. These two cannot be related. You can't work out anything from there. Leave as it is. All right, so that's it, guys. We can remove y. You can remove this y on the left-hand side by multiplying by y over 1. This y over 1 here, which is, we've got a bracket here. So that means this can cancel. We are remaining with our dy dx, which was equal to y into the whole of this bracket of 1 over the square root of x plus ln x over 2 square root of x. So that's how you play around with your what? With your derivatives from the logarithms. After, don't forget that y is given originally as x to the exponent of square root of x. So it means in place of this y that we have, we are going to substitute back. So therefore, our derivative of y with respect to x is going to be x to the exponent of the square root of x into the whole of the bracket, which is 1 over the square root of x plus the ln of x over to the square root of x. So that's it. That's the idea there. So you simply need to play around more questions, revise as much questions as you can. Where there are challenges, let us not forget to come up with the feedback so that we can work on those typical questions. So it's not like we are going to have questions which will be direct, whereby you just introduce your log, like this part whereby you're just introducing your ln direct as we are seeing here. Sometimes they might give us complicated situations, like for an example, I want us to check this part here that we're given. It's a complicated situation that you might have whereby you're given to calculate the derivative of this. All right. If we are to introduce our logarithms here, because we're asked to use the logarithmic part, so we're going to introduce the logarithms just like the previous part that we had, meaning to say we are going to have the ln introduced to this side, which is going to be the ln of y is equal to the ln of this whole part that we have here, which is the sine of 3x plus x squared, like this, over 6 minus x to the exponent of 4, everything to the exponent of 3. So this is what we have. We have introduced a ln, but this time it's different from that condition where you are given ln f of x raised to the exponent of gx, where you ended up dropping the exponent of gx, remaining with the ln f of x like this. This time, if you check these two that we are having on the ln, they are dividing. And we are supposed to get back to our laws of logarithms. Where is it that we have a over b dividing each other under a ln? What is the law on our logarithms? We know that we are going to subtract our logarithms. So it's ln a minus ln b. So from our laws of logarithms here, we are supposed to subtract. So we are supposed to have the ln of y equal to, we have ln of, this is our a on top. So this whole part is your a, this whole part is your b. So it's supposed to be ln a minus ln b. So it is going to be ln of sine. So this is ln of sine 3x plus x squared, like this. All right, so let me just remove this one so that I do not confuse you with many brackets, but we're supposed to have another bracket here. So let me remove this one and put this one here. But we are supposed to have another bracket like this to show that it's affected by ln. All right, so I can just put them this way so that I do not confuse you. I'm gonna put it this way. It's This whole part is affected by ln, all right? Minus the ln of what? Our b, which is 6 minus x to the exponent of 4 to the exponent of 3, like this. This is what we are supposed to have. But remembering also from our laws, guys, we talked about our laws of logarithms. If we are given a ln affected with an exponent like this, we are going to drop the exponent to multiply our ln. So this is going to be the ln of y is equal to the ln of everything that we have in the first place here, which is the sine of 3x plus x squared, like this. Minus, we drop the exponent because we are multiplying, we are having an exponent, so we multiply it to the log. So that's 3 ln of 6 minus x to the exponent of 4, like this. Now we can have our derivatives. We can apply our derivatives now because we have something that is in a simplest form. So remember, we are supposed to find dy dx. So here on ln y, we are going to have 1 over y dy dx, okay? Which is equal to, here we do not have a product just like what we had previously. We are having a simple ln, but let's take note of what is happening here. Let's take note of what is happening here. Remember what I said, if you are dealing with a ln, all right? I just hope this one is gonna be explainable in a way that you understand. Let me put it here. Remember, we said if we are dealing with a ln, the derivative of ln f of x in this case is gonna give us f prime f of x, f prime x of f of x in this case, which is the first derivative over the original f of x. In this case, the sign is the whole f of x, this whole sign here. So if we are to apply this concept, we're going to see that we are going to find the derivative of sine, which is inside this part of 3x plus x squared. So we want to differentiate this. This is your f of x inside. So we are supposed to work with that one. So we are saying our f of x in this case inside there, it's 3x plus x squared. So we need its derivative. This is the one that we need. So the derivative of this part here is going to give us what? That is the question. The derivative of 3x is going to give us what? 3 plus the derivative of x squared, which is going to give us 2x. All right. But we take note of the function that we are dealing. It's sine 3x. And this function of f of x for sine, we have an expression inside. So we are going to find the derivative of the sine now. What is the derivative of a sine? Sine changes to cos. So it is going to be cos 3x plus x squared. So we are dealing with sine. The derivative of sine changes to cos, but we are supposed to differentiate what is inside of the sine from our function of a function. Yes, function of a function concept. Everything over what? Here we are differentiating this part of sine over our f of x. Our f of x now, we are talking about the whole of this sine, all right? So we are talking about the whole of this sine, which is going to be the sine of, in this case, 3x plus x squared. All right, so that is what you're supposed to obtain in this case, all right? So let us check the other part, all right? I want this part here. Now we are given another part of a ln. So the 3 there is simply multiplying. It's like -3 times the part of a ln. Remember what we said about a ln. The derivative of a ln, we need the derivative of f of x, which is inside here. So 6 gives us a 0. 4 is going to give us -4x to the exponent. We subtract 1 over our normal f of x as it is, which is our normal f of x as it is, which is 6 minus x to the exponent of 4. So this is what we're supposed to obtain. So you can multiply negative, which is going to give us a positive. That will be 12x to the exponent of 3. We multiply this part, these 2, and x to the exponent of 3. All right, everything over what? This whole part of 6 minus x to the exponent of 4. So all you just need, as we can see, is to try by all means to play around with the derivative of a log or a ln, how to differentiate a ln. Once you understand that, this part is not going to be much difficult. All right, so this whole part multiplied by y, so that we remove what? We remove the 1 over y here. We remain with what? Dy dx. So that means our dy dx is going to be equal to y into the whole of this bracket that we have, which is 3 plus 2x into the cosine of 3x plus x squared, everything over the sine of 3x plus x squared in this case, all right, plus 12x cubed over 6 minus x to the exponent of 4. That is the condition that you have, and not forgetting that previously we were given y. So we are going back where we have our y. In this case, we have to substitute back the y that we are given here. So this is the one that we are going to substitute. Where there is a y here, we substitute on our final answer. So therefore, our derivative of y with respect to x is going to be the whole part of y there, which was given as the sine of 3x plus x squared, everything over 6, that was 6 minus x to the exponent of 4 to the exponent of 3. All right, being multiplied into the whole of our bracket, which is going to be 3 plus 2x into the cosine of 3x plus x squared. All right, everything over the sine of 3x plus x squared. All right, plus 12x cubed over 6 minus x to the exponent of 4. So this is the whole part that you are going to have now as your derivative of y with respect to x. Your answer is now supposed to consist of the y that you had here. You are supposed to substitute back that y that you were given before. So that is the play around of the logarithmic differentiation. As you can see, you need to introduce the logarithms first. It works on complicated situations, although you are given that use or work with the aid of logarithmic differentiation. You are already told, but what you need to know is that it is used whenever you're dealing with most complicated situations. So we introduce the ln, which is our log both sides. After introducing the log, apply the laws of logarithm, apply the laws of logarithms, meaning to say it's going to depend with the one that you are given for that one, all right? So we say the laws of logarithm, sorry for that. So the laws, they depend, like on this part, we are dividing numbers under a log, and we know that if we are dividing numbers under a log, what we are going to do in that condition is to subtract the logarithms. You subtract. If you were to multiply the numbers, it's a times b, maybe the numbers were multiplying like this, it means on that condition you were adding the logarithms, which is the ln of a plus the ln of b. So all you need is to work with the laws. And we talked about a condition whereby you are multiplying, the log is multiplying, and a number is multiplying the log. On that condition, it means it was the ln of a to the exponent of m. So they will give you this stage here. They will give you this part, and you have to convert it back to this way. They will give you this part, you convert to this way. They will give you this part, you convert it to this way. So that's the application of our logarithms in this case, the logarithmic differentiation. Know your laws of logarithms and the basic derivatives. And don't forget to say, after you have simplified everything, substitute the value of y that you were given before. This y here, you're not supposed, it's a derivative of y with respect to x. So our answer is supposed to consist of x throughout. So that's why we are supposed to see x throughout our equation or our answer. So that's it, guys, from Mason African Motives. Till we meet again.